So let's now go back to iFlow Studio, and then we want to add the post condition for the add command, and then we want to test about the post condition and also implementation for add. Let's go back to birthday book over here. We don't need a root anymore, so let's close it. Okay, let's maximize it. So what should be the post condition over here? I will start by writing the ensure clause over here. And then whatever I put over here is going to be some Boolean expression, and it can be as many tagged Boolean expression as I like. So let me explain conceptually how you should think about the post condition before we code it into iPhone. So now beware of the color I'm using over here. Okay, so now you can see the entire birthday book object is in green. Okay, I call this the pre-states. So this is the state of the objects right before I try to make this particular command call over here. Let's say I'm trying to say add. Let's say I already got Alan, Mark, and Tom. I already got Alan, Mark, and Tom, 3 records in the birthday book. And now I'm trying to add Jim and also birthday, let's say August 14th, into the birthday book. Okay. Before I do it, it's called pre-states. In terms of the pre-state and post-states, I will refer for the details, I'll refer you to the week 1's lecture about pre and post-states. But over here, pre-state basically is just the state of the objects before the command or query is actually called. Okay, and then the post-states is already assuming that the pre-state already satisfy all the precondition for this particular command, and then executing the implementation will bring you to the post-states. The post-state is basically after all the changes have been made by the implementation. Okay, so now I'm going to use the red color to actually annotate what has been made as changes to the pre-state, basically. Okay. So now let's remind ourselves what the implementation will do. It's going to extend the name, extend the birthday, and also increment the count value by 1. Okay, so now let's see that. So again, we already got pre-state, which is the entire object over here. By executing the add, we're going to do 3 things. Number 1, we're going to extend Jim over here into the names array. So now index 4 is going to be Jim. So that's the post state already. And then we're going to also extend this particular birthday August 14th, right? So now there will be another record over here, number 4. So that's going to be August 14th. And then of course we're going to increment the counter. So it's going to be from 3 to 4. So now, what about the post condition? Let's try something that may not be as complete as satisfactory. For the complete post condition, we'll refer you to week 2's lecture materials. But for now, we'll do something that at least can show you some introduction. Okay, what we want to do is we want to ensure, number 1, because we're inserting at the end. Let's say that's our assumption. So we want to make sure, first of all, the counter. If you compare the pre-state value and the post-state value, you can see very clearly the pre-state value. The way we refer to the green one is by saying the old version of the count. Okay. Also, in terms of the more sophisticated use of the old keyword combined with other things like object copy, deep copy, shallow copy, reference copy, I'll refer you to week 2's lecture material. But for now, let's do something very basic. In order to refer to the pre-state value, I'm going to use the old keyword, and then I'm going to say old keyword plus 1 will be exactly equal to this post-state value, in which case I'll simply just say count. Okay, so this will be the equation I need to write back to iFlow Studio. Okay, so let me just emphasize that. So that's the number 1 we're going to say. What about number 2? Let's say we want to say also this is the new count, right? It's actually 4. So we want to say bb.names at position count. In this case, it's just going to be 4. So that one should be exactly just Jim. Okay, that's the second one. Okay, that's the second post condition we'd like to do. What about the third one? Well, similarly, we want to make sure this date has also been added. So it will be something like bb.birthdays at position. So that should be the count value, the latest count value. That should just be count. You only use the old keyword if you want to refer to the value prior to the routine call, in which case that would be the pre-state. Okay, so that'll be equal to, well, August 14, right? I'll just say August 14, just conceptually. Okay, so that'll be the sketch. So these are the three post condition we want to write. Number 1, number 2, and also number 3. Let's see how we can do each one of them back in iFood Studio. Okay, let's go back here, and then let's also give some meaningful tag for each one of them. Okay, I can say number 1, let's say count incremented. Okay, that's exactly what I said before. You can say, for example, count equals old count plus 1. Right, that's exactly the first one I said over here. Okay, over here. And then what about the other two? So let me say something like a name added to the end. So I can say over here, names array at position the latest count value, in which case the latest count value, as I said before, it would just be 4. So index 4 and also index 4 over here. Okay, so I will do over here. So let's say count and use tilde to actually compare objects for the string, right? Tilde, and also we're gonna say should be the whatever name it is. Of course, in that particular example, it's simply just Jim. But in general, it should just be whatever the parameter value is. Should just be name. And also, let's say birthday added to the end. And I can say birthdays at position count, right? Similarly, and then that would be simply the argument's birthday here. And we know very well this will also work because we already redefined the isEqual query for the birthday class in the previous video. Okay, so now these are the 3 post conditions we have. So now we would like to do 2 more tests for completeness. We want to write a test for implementation, and we also want to write a test for post condition violation. Let's start with the implementation test, in which case we don't expect any violation to occur. So it should be a Boolean test query. Let's go to test birthday book class, and then let's add a feature section over here. Let's call that, let's say Boolean test. Okay, and we're going to test the add. So let's say T, how about just add over here? Just make it simple. Of course, as your number of test cases get large, you may want to have a more systematic names for your test cases. But for illustration, I'll make it simple. And always put the comments first. T add test addition to the birthday book. Okay, it's going to be a Boolean test, so don't forget it should be a Boolean query. Okay, you should always put it first. I didn't, but I should have. Okay, and make sure before you forget, you should also again, actually, you know what? Let me just be a little bit more systematic over here. Why don't I have another section over here? Let's call it a Boolean test. And then I'll say add Boolean case agent T add. Okay, just make sure everything compiles. Okay, maximize it. Okay, so now what should we write here? Let's just do some simple test cases to test the add. We can add maybe up to 3 records to the birthday book. Let's say local here, and then birthday book is going to be birthday book. Okay, let's say we got BD1, BD2, BD3, and then we can have, let's say, birthday. So let's start by creating an empty birthday book. So we can say create bb.makeEmpty, and then after that we can do some tests quickly. So we can say result is assigned to bb.count should be equal to 0, and also bb.names.count should be equal to 0, right? Just checking that names and birthdays there have the count 0, and also bb.birthdays.count over here also equal to 0. Okay, let's make sure everything compiles, and then let's run the test just to make sure at least the empty birthday book is actually fine. Okay, so that's exactly the test we were trying to run, and let's try to do addition. Okay, so let me maximize it. So let's try to do 3 additions maybe. So make sure you put the intermediate assertion here. That's important, so we don't miss anything. So now we can say bb.add over here. Let's say we have, let's just be consistent with what we set on the iPad. So Alan, September 14th, right? Let me take BD1 just for now. Okay, I'm gonna put actually let me put it at the same time. That might be better. So create BD1 dot make September 14th. Let me remind myself. And then March 31st and July 2nd. March 31st and July 2nd. Create bd3.make July 2nd. Okay, so these are the 3 birthdays, and then I'm just going to add 3 times over here. Right, apparently you can see I'm trying to make some variety for use. Either you can use anonymous objects or you can use some name objects. So you can definitely use either of them. 1, 2, 3, Alan, Mark, and also Tom. BD1, BD2, and also BD3 over here. And then we can do things like result is assigned to bb.count is equal to 3. Okay, we can also check the count for the names and also birthday. But let's just do something. I'll just do something incomplete for you so you will see the idea. I can say, for example, let's say bb.names over here at position 1 should be equal to Alan. And also bb.birthdays at position 1 should be equal to. So now either you can say BD1 itself, or you can create another birthday with the same, also September 14th, or I can use anonymous object. In this case, you may want to use parentheses to really bracket it. So make sure the compiler can read it properly. So I can say creates birthday, because we added for Alan BD1, which should be September 14th, right? For make over here, so that should be September 14th. Okay, so just make sure I undo that. Okay, so that would be it. Let's just make sure everything run. You can do the other 2 records in the birthday book. Okay, so a very quick test just to make sure our implementation is correct. And now we're going to test specifically about violation of the post condition. So please recall that previously we did a post condition test already. So this is the notes from the previous one. So we're going to do exactly the same. But now we're going to create a subclass of not birthday, but instead birthday book. And then the structure of or the architecture for the setup will be the same. So this time, rather than coding first, let me go over the architecture with you very quickly. Okay. So let me first of all go to that particular template over here for the architecture. Okay, so what we're going to do is we're going to this is the class with the correct implementation. So we are trying to test the add with the correct implementation. What we want to do is we want to create an incorrect implementation that will violate a particular post condition with some specialized tag. So this is let me use orange here. So this is the subclass that we want to create. We'll simply say, let's say birthday book violating name added to end. So it's suggesting that we want to violate this particular post condition specifically, right? In order to violate it, we want to make sure we modify the implementation in the subclass such that the last item in the names is not going to be what we want, what we intend to set it to be. However, on the other hand, you can notice that the position of this particular post condition is after the first one. So you want to make sure this one actually can check, this one can pass. Otherwise, you never get a chance to check this one here. And this one, we don't care, because once the post condition violation occur over here, you have no chance to actually check here. So you should always consider where exactly is the post condition you want to check for violation, if that's expected, right? So, and then we also going to use the test. Oh, so rather than test birthday here, it should be test birthday book. Okay, I just made a typo here, but you can see what I mean. Okay, so let's, at the runtime, what's going to happen is, when we try to, we're going to use a B, oh, rather than BD, it should be birthday book. BB, again, is a typo. Okay, so in the actual run, the implementation that is going to be called is going to be a wrong version of the implementation. However, this particular subclass over here is going to inherit this all the contracts over here. So it's really important to note. So all these contracts over here are going to be inherited over here. is going to be inherited. Again, it's called something called subcontracting, which we'll talk about later in the course. And the wrong implementation will be checked against 1, 2, and 3. And we want this one specifically to make sure it can really be triggered when the last element of the names array is not the name. Okay, that's exactly how we're gonna achieve it. So hopefully you get an architecture here, and then we're gonna code it out. Okay. If necessary, I'll come back to this diagram. Otherwise, you can look up your notes. So now let's go back to iPhone Studio. And first of all, let's create, let me go back to test birthday book. That's good. Let me create a new class for that particular bad version of the descendants over here. So that will be, let me just go back to here. Click on the, you can see under the post condition, right? We already got one class from the previous video. Click on this postcondition subcluster here and click on add a new class, and let's call that birthday underscore book underscore violating underscore name underscore added underscore to underscore n. So that's a tag name. It's a very long name. But I would say in your case, you can create this bad version of the descendants in whatever way you like, as long as you're consistent with your naming convention. Okay, so let's say creates over here, and according to the architecture over here, I should say compile over here. According to the architecture, it should inherit from the birthday book class over here, right? It should inherit from the birthday book class. Let's do that, and then we're gonna redefine the add command specifically. So what I would do is I'm gonna say over here inherits the birthday book, and then specifically it's going to explicitly redefine or overwrite the add command over here. Okay, I'll say n, and then you want to make sure also specify the constructor. Otherwise, you cannot create this particular subclass, create an instance from there. So it will just be make empty, right? If you recall from our birthday book, the constructor is also make empty, and now we need to copy and paste the exact header over here, right? That will, and also I would suggest we just copy everything until the implementation. We copy the correct version there. I'm going to modify that in a moment. Okay, so now let's go back to the birthday book over here. Okay, and then we're going to say over here. Okay, copy that and paste. Okay, let's create a section over here. Let's say feature command. And then let's fix the indentation quickly. We don't need to repeat the precondition. Okay, and now let me just make a note over here. This is the correct version of implementation. And over here, the post condition is inherited from the birthday book. So there's no point to repeat it, right? So implicitly, it's going to be inherited from the birthday book over here, right? Go back here. And now, how can we modify that? We want to modify that in a way. It is going to, first of all, it's going to satisfy this. Actually, count equals O count plus 1. It's definitely satisfied by this particular assignment. So we don't change that. Let's leave that, okay? And now we want to make sure names that count, names at position count is not equal to name. That's the one we want to violate, right? So I would say it's an easy one. Okay, we want to say, how about let's consider the following crazy implementation. Not when the birthday is empty. When the birthday is actually, let's say, have size more than 1. Let's say size of 2, 3, 4, 5, etc. We're going to actually replace in the following way. Okay, let me just write it down. If, so this might be the first time we'll see the if statement. It's actually very easy. So as soon as you hit the if, you can say space. It's going to complete the code for you. Let's say if, let's say the following. If the count of the birthday book is actually larger than 1, which means either 2, 3, 4, 5, etc. Right? So that means after this particular insertion, the size of the birthday book might have just become 2. Okay. In that case, we're going to replace the following. So we're going to say we want to change the name. So we can say names at position count is assigned to names at position count minus 1. So you can see the count larger than 1 here is just to ensure the count minus 1 can always work as a valid index. Otherwise, we get something that sounds like an index violation unexpectedly. Okay, so we're going to see exactly how this is going to work. So let me just say this. Let me make some documentation here for you. So that's a ROM implementation. Let's say, for example, when after the addition, if the size of birthday book is 2, then replace the last name by the second last name. Okay, I'm going to show you exactly how, but just make some documentation. So this ROM implementation here will make sure we can satisfy the very first post condition over here. As you can see over here, we can still satisfy it, but it's going to fail this one specifically. So the exercise you may want to think about, can you just create another bad descendant class so that you can satisfy the first one, you can also satisfy the second one, but you're going to fail the third one, right? So you want to test post condition by post condition. For each post condition you want to test, you want to create a new class. Okay, that's how we can exploit the inheritance. Okay, so that's good. So let's, the test is done. The setup is done. So why don't we go back to our test, birthday book. Let's go back there and let's add a new test case over here. Okay, under violation tests at the end, let's say T post condition add, let's say, and then do an end. So now still it's going to be a command rather than query. So we'll say comments over here. Let's now copy this name over here and then put colon, test the post condition of add with ROM implementation. And more precisely, the tag that we want to trigger is this particular one, right? The second one. That's what we wanted to trigger. So why don't we put that in the documentation for the test? The post condition of add with tag by a ROM implementation. Okay. So let's declare the local variable over here, and the local variable should be of type, according to the architecture, it should be of this particular type, right? It should be the birthday book violating name added to end, the bad subclass. Local, let's say BD, okay? Or you can say bad BD if you like. So let's say birthday book violating name added to end. Okay, so that's the subclass we would like to put. Okay, just make sure everything compiles, and then let's maximize it. So now what we will do is, first of all, create bd.make empty. Okay, that's fine. So this one is not calling add, nothing is going to happen. And now when we say bd.add over here, let's say here we put Alan over here, and then we'll say create some birthday on the fly. So create birthday.make. For example, July 2nd. Doesn't matter. Is this one going to trigger a post condition violation? Well, you can take a look. If you go back to the bad version over there, you can see we only execute this bad implementation when the count is actually strictly larger than 1. After, in this case, after adding the first record here, the count will be 1, which is not strictly larger than 1. So this one is fine. Okay. So now post condition violation not expected, not yet. And then we're going to say bd.add over here. Let's say Mark, right? Yep. Of course, if you say Alan here, you're going to get a precondition violation, right? It's going to be unexpected. So that's why we're going to choose a different name. Mark, let's say create birthday.make over here, August 15th. Yeah. The ROM implementation. So what we expect to see is in the post condition over here is expecting to see the last elements of the names should now be Mark. However, the ROM implementation over here is going to the ROM implementation is going to replace Mark by Alan, right? Alan is actually the count minus 1 index, which is index 1. Okay, hopefully you can see that very clearly. Let me go back here. the wrong implementation will replace bb.names at position 2, right? After the addition is going to be two records with bb.names with the assignments 1. That's exactly what's going to happen. And make sure you also include this violation test in the test execution. So add violation case with tag over here, and just to avoid having a typo, why don't I just go back, and then I'll simply copy the tag and then come back here, come back to the test over here, yeah, and then I'll simply paste over here for the tag. If you spell wrongly the tag name, it's not gonna happen, right? It's not gonna work. Okay, so now we can say agent t postcondition add. Okay, let's now hit compile. Okay, let's now run the workbench system. Okay, good. So everything works. You can see the postcondition really has happened expectedly. Okay, let me just do something here very quickly for you, just in case you're still a little struggling with understanding this postcondition test. Okay, so why don't we try the debugger very quickly? Okay, so now click on the feature tag over here, and then highlight, and then right click to drop all. Yeah, so right click on this, and then right click to drop. Okay, let me do it again. Highlight, right click, and then right click to drop. Okay, it's already there. What I want you to do is put a breakpoint over here for the second call right before it. And now if I try to run over here, okay, now I'm pausing. Oh, that's a precondition add. That's a previous breakpoint, so I can just delete it. Okay, just click one single click and then to remove it, and I can keep going. I say run, and then I think that's the expected precondition violation from before, so I'm okay with this. Okay, so let me just say run again. So now I'm right before this particular add, right? So now in order to see how the postcondition violation occurred, let's see. So now you can see BD is actually of type birthday book violating name added to end. So if I say step into over here, it's going to switch to the context of the add command. But which version? Is it going to switch to this particular version over here, or is it going to switch to this particular version here? Well, because the dynamic type is actually this class, so it should be this version here, right? Very quickly. So now if I say step into, so now you can see again it's creating the anonymous objects, right? Very quick way for you to skip, put a breakpoint over here, and then you say run, okay, and then make sure you remove it, okay, and then say one step at a time again. So now we are in the add command. However, look at which context we are. It says that birthday book violating name added to end, right? So now we're really in the right version. And you can see we're gonna simply just try to execute line by line. Okay. You can see now, up to now, we actually have done the correct version already. So now why don't we try the following? So let's say names at position 1 is Alan, and also names at position 2 is Mark. So far, so good. Okay, now I want you to watch very closely, right? So now because names the count is the count is actually larger than 1 is 2. So now it's going to execute this particular assignment over here. So now it's going to modify names the count is going to be Mark. Replace that by the previous one, which is Alan. So I want you to watch very closely what I'm highlighting here, right? As soon as I say step one step at a time, you can see it's been changed from Alan to Mark. Sorry, from Mark to Alan, beg your pardon. It's been changed from Mark to Alan, and apparently this is the wrong implementation. So now we get Alan and Alan. Apparently it doesn't make sense. And now let's see exactly which postcondition will be violated. Count equals outcome plus 1, because you can see the count has been incremented from 1 to 2. So this is not an issue. So if I just try that, it's going to be fine. But now, when I say names at position count, let's see this. Count currently is actually 2. So if I say names at position 2 is actually Alan. Is Alan the same as the name we are trying to add in? What's the name we're trying to add in is Mark. Alan is not equal to Mark. Apparently, this one is going to be violated. So if I say one step at a time, So now I got exactly this particular postcondition violation with this particular tag, name added to end, right? So that's the whole process of understanding how this postcondition violation happened. Please make sure you really understand this. I think it's a very good case study and application for inheritance. Also to understand about how you can trigger the violation for some particular postcondition. Okay, the one final thing I would like to do is to go back to the precondition for the add quickly. Okay, let me just go back to birthday book. Let me close this one, only the birthday book. So this is the precondition that we did previously by using the has. Given that we already set the object comparison of the data structure to be true, it's always a good practice for you to do so. So for now, let's say Control K to put it into comments. What we like to do is, why don't we try to translate this using universal or existential quantification? So let me show you both ways. Let's do a literal translation. Let's say, first of all, let's say not, and let's say put a parenthesis over here. If you only consider this expression alone, so we are saying that at least one name in the names array is equal to the argument name over here, right? You can see at least one name that's in the names is equal to the name over here. So we can use across some, right? So to really see how to use across some, across all, you can refer to the previous video. So I can say across and then change from S to is right away over here before I forget. Let's say across. So now for the array, I can either use the integer interval for the indices, or I can simply go across the arrays, because now I don't really need an index specifically to do anything. Like in the sort is like a sorting, right? So I can say across the names is local name over here, and then over here to really correspond to this particular one over here, I'm going to say sum L name is equal to name over here. Okay, so that's one way to do it. Okay, so that way it's really like a literal translation. Not is not over here, and this guy here is this particular existential quantification over here, right? Let's now compile and make sure everything still works, which means the original precondition violation is has still happened as expected. Let me come back here. Let me just do one more, okay? So now to do the next one, let me remind you very quickly a important conversion theory that you did in your 1090 logic course, right? Very quickly. So let's say this. If you have for every x, right, such that some range expression is satisfied, it is the case, px, right? Some predicate, right? So this part is the range. And this part is the property. Okay, so now it would be always equivalent to the corresponding existential quantification and vice versa. Okay, so what would that be? So you'll be double negation. If every x is satisfying this, so that means it is not the case that every x does not satisfy that. So now not the case, there exists an x such that Rx, and then not the case, Px. Okay, very quickly. So this one's to saying every x in the range satisfy P. So this is saying it is not the case that there's at least one x in the range that does not satisfy P. So that means every one of them actually satisfy it, right? So you learned about this previously. So you can always do conversion from for all to exist and vice versa. Okay, that's something I would like to remind you. So now let's go back here, and then can we actually potentially convert this into for all? Yes, we can. Okay, let me again put this into comments. So now what we will do is for this one over here, okay, just for this one here, let me just do very slowly together with you, because that might be the only time we'll do this in this tutorial here. So let me just copy this guy over here, okay, just for now. And then this is just copy verbatim. For this one here, it's going to be not at the front, and also change this to all, and also negation over here, right? Agree? And then not and not should be cancel out, double negation. So now we don't need a not here, we don't need a not here. Okay, so we can also get rid of the parentheses. Okay, so now it's saying that in order to say the name actually does not exist, we're saying for every name that's in the for every local name that's in the names, it is the case that the local name is not equal to the name. That means every one of them is not the same. So it's not the same. So the name does not exist. Okay, this one also works, but this one just doing a little bit conversion. So logically speaking, these are equivalent to each other. Which one to use is completely up to you. Okay, let me compile and then let's run the workbench system again to make sure everything is okay, right? Everything's okay. So now I want you to really pay attention to the details for making this one to work and why these two are just equivalent to each other. Okay.